Hello everyone. Today is our Somerset Math Circle Club lecture number 5. Today we have again 3 parts. First part, expressions and linear equations. Expression, the definition is for numbers, variables using mathematical operations from expression. And here's the definition for term. Well, we'll get a feeling by working on practice problems. First, practice problem number 1, A. Are r squared over r and r equivalent? Okay, when r is not equal to 0, r squared over r, we can divide r from numerator and denominator. So that would give you r squared over r, divided by r from the top, divided by r on the bottom. That would give you r. So r squared over r and r are equivalent. When r equals to 0, then there is no definition because you cannot divide anything by 0. That will be infinity. So then here, they are not equivalent. B, are t plus 1 and t minus 3 equivalent? Of course, these are different because t can be one value. Here you add 1, here you subtract 3. So these are not equivalent. C, are 12 over 4x and 3x equivalent? In here, 12 over 4 is 3x, therefore, they are equivalent. Problem 2, A. Express a over 2 plus 6a minus 5 over 4 as a single fraction. So here, basically, you have to collect like terms. First term is a over 2, plus second term 6 over 4, which is 3 over 2a minus 5 over 4. Then you collect like terms. Here are all the a's, here are the numbers. Or you could do it as, so here the base, the denominator is 4, here the denominator is 2. We can change them into the same. Therefore, the first one you multiply 2 on both numerator and denominator, then becomes 4. The top is 2a plus 6a minus 5. Collect like terms, then it will give you the final answer. B, express 2x plus 7 divided by 6 minus 9 minus 2x over 9 as a single fraction. So here, again, we follow part A. 6 and 9, we need to find the least common multiple. Then we can make this as, so 6 and 9, what's the common multiple? 6, 9. We can divide by 3, here's 2, here's 3. Least common multiple is 3 multiply 2 multiply 3, which is 18. So we use 18 as the common denominator. Here, the top has to multiply 3 minus this has to multiply 2. You break the brackets using distributive properties, and you collect like terms for x and all the numbers that will give you the final answer. Problem 3, simplify expression 5 brackets z minus 3 plus 3 multiply 7 minus 2z. So distributive properties again. So 5z minus 5 multiply 3, which is 15, plus 3 multiply 7, 3 multiply negative 2z, like terms, then we'll give you the final answer. So these are relatively straightforward. So we'll, the final answer we'll leave for the students. Simplify expression. Here are 4 terms. We need to find the least common multiples of all 4 numbers. We have 4, 3, 7, 6. We can first use 2. So this is 2. This cannot be divided by 2, so carry down. 7 cannot be divided by 2, so carry that down. This divided by 2 is 3. We can use 3 again. 2 cannot be divided by 2, so carry that down. 3, 3, that's 1. That's 7, that's 1 again. So least common multiple, 2 multiply 3 multiply 2 multiply 7. So this is 4, 12 multiply 7, that's 84. So we change all the denominator into 84. So you multiply numerator correspondingly to get to the final answer. Linear equation. An equation is linear equation if every term in the equation is a constant term or is a constant times the first power of the variable. So we'll see this. For example, if you have unknown of x, 2x plus 5 equals to 20. For example, this is a linear equation. You only involve x to the power of 1, multiply some constant, some number. So let's look at this linear equation using some examples. Practice problem 4. Solve this equation. So we have a few rules to solve equations. For example, using this as example, so you have number and unknown on one side. The goal is to move all the numbers all to one side and all the unknowns stay on the other. So in this case, we can add, we can subtract, we can multiply or divide the same number to each side of the equation without changing the equality. So in this case, we can do 2x plus 5 minus 5 on both sides. That would give you, so these two would cancel. Left side would give you 2x. The right side would give you 15. Okay, so now all the numbers on one side, all the unknowns on the other. Now we need to get rid of the coefficient right in front of the unknown. Here is a 2x, so we divide the equation on each side by 2. Now the left-hand side is x. The right-hand side is the number that we want for the unknown. So the goal is to get to x equals to something, okay? We can move the number to the right-hand side first and then get rid of whatever constant in front of the unknown. Let's use these as an example. So we have 24 equals to negative 75y. Okay, in front of the unknown y, there's a negative 75 multiplying to the y. So we can divide each side by negative 75. Therefore, the right-hand side becomes y. The left-hand side becomes 24 over negative 75. So that is y is 24 over 75. There's a negative sign too. Okay, students can simplify this answer. This one, so unknown is on left-hand side, unknown divided by 7 equals to this. We need to get rid of this divide by 7. How do we do that? We multiply 7 to both sides of the equation. So now left side is u, right side is 3/2. So the goal is to get to this stage. Unknown equals to some number. This is the answer that we are looking for. We either subtract some number from each side or multiply to each side, the left and right side, to get to what you want. Okay, this one, we'll leave this one for the students to figure out. This one is relatively simple, just as the previous two examples. You have negative 2 9s multiplied the unknown r equals to this. So we can just divide each side by negative 2 9s to get to r equals to something. This example is relatively complicated. So x minus 1, the unknown, is on the denominator. It is the same as if it's on the numerator. We can multiply each side by x minus 1, 7x minus 1, multiply x minus 1. Remember, when we multiply, it has to be multiplied to the whole side of the equation. So here we only got one term. As we will see later, when you have, for example, like here, you have two terms. When you try to multiply something, you have to multiply to this whole thing, not just one term of it. So here, if we multiply x minus 1, left side is 7, right side is 1/3 x minus 1. So we can get rid of the 1/3 by multiplying 3 to each side. So left side is 21, here is x minus 1. Okay, x and number on the same side, move this number to the other side by adding 1 to each side. So now these two cancel. That would give you x equals to 22. So the goal again is to get to x equals to some number. Move all the numbers to one side and keep the variable on the other. Okay, this example, again, we have this whole thing divided by 9. We need to multiply the whole side. 2r minus 7 divided by 9. Multiply the whole left-hand side by 9 to get rid of the denominator. And you do the same to the right-hand side. So these two cancel, equal to 1, and 2r minus 7 equals to 27. How to get rid of this? We need to add 7 to each side to cancel this one. Then you get 2r, and then you divide each side by 2 to get to r equals to something. We'll leave this for the students. For this problem, it's the same. So you have this left-hand side divided by 5 and right-hand side divided by 7. We can multiply 5 and 7 to get rid of both sides. So in that case, we have 3x plus 4 multiply 5 multiply 7 equals to 2x minus 8 divided by 7 multiply 5 multiply 7. So right-hand side, 7 cancels. The left-hand side is a 5 cancels. So you have 3x plus 4 multiply 7 equals to 2x minus 8 minus multiply 5. So distributive properties, we carry this out. 21x plus 48 equals to 10x minus 40. Move the 10x to the left-hand side. Move the 28 to the right side. Then eventually you would get to x equals to something. G. 8y minus 13 1/2 equals to negative 2 1/7. In this case, here is one number, and here's the unknown. We move the number to the right-hand side by adding 13.5 to each side. And on the left-hand side, you would get 8y. The right-hand side is negative 1/7 plus 13 1/2. Then we divide left and right side by 8 to get to y equals to something. Okay, this problem. We have different ways of solving this. If students find the fractions are difficult to deal with, we can get rid of the fractions first. So we have 5 and 3 on the denominator. The least common multiple of the 2 is 15. So we multiply 15 to each side. 9/5 minus 2/3 x. Multiply 15. Remember, the multiply 15 has to multiply the whole side, not just one term. You bracket each side, right? The left side multiply by 15, and you do the same for the right-hand side. You bracket the whole side first, multiply that by 15. Then carry this out, distributive properties. Then you would get to how many x and numbers on the left-hand side, and you have x and number on the right-hand side. Then you collect all the x on one side, move all the numbers to the other by subtracting or adding the same number to left and right side. And eventually you would have some x equals to some number. Then you divide this to each side to get to x equals to something. We'll leave for the students to figure this one out. Find all values that satisfy 2z minus 8 minus 5z equals to this. Okay, we have z here on both sides. We collect z first. So 2z minus 5z, that's negative 3z, minus 8 equals 2, minus 3z, 2 minus 10 is minus 8. So left side always equals to the right side. So it does not matter which number z equals to. These two will always be equal. Practice problem 5. So we have these 4 problems just to tell the students how do we use the numbers to convert them into equation. So 7 more than twice of what number equals to 35? Okay, say this number, unknown number is x. 7 more than, so 7 plus twice of this number equals to what? 35. Here is the equation to convert the words into equation. So this is a relatively simple equation to solve. We'll leave for the students. Problem 6. When you add 12 to a number and divide the sum by 13, you get the same results as when you subtract 13 from the number and then divide it by 12. Okay, if that number is x, you add 12 to that number and then divide the sum, remember, divide the sum by 13. You get the same results equals to as you subtract 13 from this number and divide the difference by 12. That's how you convert the words into equations. So here, denominator of 13 and 12, if we want to get rid of the 13 and 12, you multiply 13, and multiply 12 again to get rid of this. Then you have x on each side. You collect x on one side and move the numbers to the other side. Then you can solve this equation. Practice problem 7. A garage has 17 cars and motorcycles. Altogether, there are 56 wheels. How many of each type of vehicle are there? Okay, let's just say 17 cars and motorcycles. I will say cars equals to y. The number of cars is y. And the number of motorcycles is 17 minus y. Okay, altogether there are 15 wheels. Cars, they have how many wheels? 4 wheels. 4 multiply y. Plus, motorcycle has how many wheels? 2. 2 multiply 17 minus y. Total wheels are 56. Problem 8. 3 years ago, I was 2/3 as old as I will be 8 years from now. How old I am? How old I am right now, see, I'm z years old. 3 years ago, z minus 3. I was 2/3 as old I will be 2/3 as old I will be 8 years from now. 3 years ago, this is my age. And this age equals to 8 years from now, z plus 8, the 2/3. So that's how you write out the equation. So this is relatively easy to solve. You multiply 3 on each side and break the bracket using distributive properties, and you can solve this.